Hi guys, I'm Eddie. So this video is also on low-hanging fruits, but that is the second section where you can score some very low marks, which is on free body diagrams, right? From free body diagrams, there are some key points that one needs to remember. First, which is the need for one to draw a reasonably sized dot, like the one that I'm drawing here as an example. Then after drawing a reasonably sized dot, one needs to know that you must also have your arrows pointing away from your dot, like this. My arrow is pointing away from the dot. I can also have another arrow pointing away from the dot. Then, after drawing your arrows, you must provide some clear labels. For this, if your object is moving on a surface, then you know there should be normal force. Then you must also have your force applied. If there's force applied, these are clear labels. But if you did not use labels, you might also use symbols. So if you have drawn a symbol, you have used a symbol, you must provide a key wherein you tell us that what does W mean? It means weight in this case, right? So if you have provided a key like this, then this gives basically a very simple example of a free body diagram which is completely labeled, right? Let's have a look on one of the questions, which is the questions on Newton's second law, which needs us to draw a free body diagram, right? I've zoomed the question very closely so that we can have a clear look, right? 2.1, draw a labeled free body diagram showing all the forces acting on the crate. Now, the first thing is, I advise you to sketch the surface on which the object is moving. Then you place your reasonably sizable dot onto the surface to represent the object. When you have your dot on the surface, then now what you need to do is to go through the question and find out which forces are involved. Fine. There is force applied, which was there, that was applied at an angle. So you have force applied. Right. As the object is resting on the surface, there is always weight, which is towards the earth's center. That is your weight. Then from the weight, there is normal force, which is always perpendicular to the surface. Then if your object is moving to the right, then it means you are going to have your friction going to the left. What guides you on the number of forces that are required is the number of marks that are allocated. 4 marks are allocated to this question. Therefore, it means also 4 forces are needed for you to score your full marks, right? Let's have another look on another question which needs us to draw free body diagrams. This is a question 5 on work, energy and power. Question 5.1. There are 3 marks there, meaning I must draw a free body diagram of 3 marks. The free body diagram showing all the forces acting on the boy skateboarding whilst moving between point P and point Q, right? The boy is moving on an inclined plane, so I'm sketching my inclined plane like that. Then after sketching my inclined plane, I'm drawing my sizable dot first. That is the first point for us to draw the free body diagram, right? After having my dot, I know I must have 3 forces since this object is resting on a surface. So my normal force is that one, which is always perpendicular to the surface, and always force of gravity, which is pointing downwards. That gives us the weight. Since the object is sliding down, then friction goes the opposite way. That gives us friction, right? This gives us the 3 forces that are stated there and guided by the number of marks which is provided by the question, right? So, and now we have got our free body diagram. There are some key things that I just wanted to hint to you guys on a free body diagram. You should make sure that all of your forces are in contact with the dot, and also make sure that all of your forces, you've got some arrowheads to show that these are vector quantities. And please also make sure that all of your forces are drawn in straight line. Thank you.